Hi folks, we're going to take a look at page 83, number 18. So here they're asking us to determine the value of this unknown a, given that this line is tangent to the curve y equals a over x squared at x equals negative 2. Okay, so let's see what this would look like here. So I kind of know this function is probably going to look something like this. Okay, so I'm interested in x equals negative 2. And this line here is tangent to the curve at that point. Okay, so let's just recall what it means to be a tangent line. Okay, so first of all, we know that they're going to share this point. Okay, at x equals negative 2. And we know that the slope of this tangent is equivalent to the derivative of this function at x equals negative 2. Okay. So in this case here, you might be tempted to, work with the derivative function, which would make perfect sense. So let's see what that gives us here. So if I solve for y here, that's going to help me get the slope of the function at this point. Okay. In fact, it will be the slope of the tangent at any point since it's a line. So let's solve that. So we have negative 4y equals negative ax minus 21. So y is equal to a over 4 times x plus 21 over 4. Okay, but what I'm really interested in is that the slope of the tangent, in other words, the slope of this line, is equal to a over 4. So what we can do is say, well, let's try to find the derivative of this function at x equals negative 2 and see if that helps us out. Okay, so again, I'm going to rewrite y here. Instead of a over x squared, I'm going to write it as a times x to the negative 2. Okay, so we have to get used to rewriting these things in such a way that we can use our rules to determine the derivative. So here, derivative is a is just a constant. So we have negative 2 times x to the negative 3. And so here y prime is equal to negative 2 over a, the a shouldn't go in the denominator here, so negative 2a over x cubed. Okay. Now here we're specifically interested in the point x equals negative 2, so we'll find y prime at negative 2, and when we stick that into our equation, we get negative 2a, and here negative 2 cubed is negative 8, and simplify these, and we see that we just get a over 4. Okay. So essentially what we've managed to show is that, well, yeah, the derivative is the same as the one on this line, so it is tangent. So while this, was a reasonable thing to try, looks like it's not really working here. It's not helping us to determine what a is equal to. Okay, but let's now use the other thing that these two functions have in common. Okay, because they're telling us that this line is tangent to the curve, it means that they share this point. Okay, now I know the x value for this point here, so what I can just do is find the y value and then input it into one of the other equations. So I actually think it's easier to find the y value through the curve here. Okay, so I have y at negative 2 is just equal to a over negative 2 squared, which is just a over 4. Okay, sort of surprising, exact same thing as we got before. Okay, and now what we can do is we can input this y value and the x value of negative 2 into the other equation. Okay, so let's do that here. So in essence, we're solving, a system of two equations and two unknowns, because we knew the x equals negative 2. What we didn't know is the y value and the a value. And lo and behold, we have two equations given that share these values. Okay, so essentially what we're doing is we're solving two equations and two unknowns. So now let's take this information and put into the equation of the line. Essentially we're doing a substitution. And so what we have here is we have a times x, which we know is negative 2, minus 4 times y, which we just determined was a over 4, okay, plus 21. Equals 0, and look what we have. We have a single unknown here. Okay, and it's in fact the one we're looking for. So this is negative 2a. Okay, 4's cancel out, minus a plus 21. And so here we've got negative 3a, bring the 21 to the other side, equals negative 21. And so a is just equal to 7. Okay, so a bit of an interesting problem because it wasn't essentially solved the way we might have thought. Okay, one would assume that we'd solve this question using the derivative, but turns out that didn't give us any information. So we had to use that other connection between the tangent and the curve, and it's that they share the same point. Okay.